Hi everyone, today we're going to study organizing data. That is, we will study frequency distribution. First, let us define some terms. The first term is ungrouped data. It means the data is raw. That is, it's not sorted into categories or groups. Second term is frequency. Frequency is the number of times a value of the data occurs. Next term is the relative frequency. It is the ratio, fraction or proportion of the number of times a value of the data occurs in the set of all outcomes to the total number of outcomes. The formula will be like this: Rf equals F over N times 100, where F is the frequency and this N is the total number of frequency. Next term is cumulative relative frequency. It is the accumulation of the previous relative frequencies. To find the cumulative relative frequencies, add all the previous relative frequencies to the relative frequency for the current row. And the last term is grouped data. In this case, the data is grouped into classes. There are steps in constructing frequency distribution. Step 1, we will make a table as shown. It means there will be 5 columns. For step 2, arrange data value in ascending order and place it in column A, that is for ungrouped data. Step 3, tally and count the data and place it in column B and C. Step 4, find the relative frequency of values in each class by the formula Rf equals F over N times 100. Step 5, add all the previous relative frequencies to the relative frequency for the current row. Let us see example 1. 20 students were asked how many hours they worked per day. Their responses in hours are as follows. These are the data. Construct frequency distribution. First, let's have our step 1, and that is to make a table with 5 columns. In step 2, we will arrange data value in ascending order. So we have data starting from 2, 3, 4, 5, 6, and 7. For step 3, we will tally each raw data in the dataset and put in the corresponding data value in our tally column. So in here, it means 3 times the number 2 appears in our data set. The same is true with number 3, 5 times it appears. For number 4, 3 times, and so on and so forth. For the frequency column, we will simply count the tally. So it means to say, for number 2, 3 times it appears, so we will write here 3. So for number 3, it is 5, so we write here 5. For number 4, there are 3 tallies, so we write here 3, and so on and so forth. And then we will take the total, and this is now equal to 20. This 20 must be the same with how it is described in our problem. So it's written here 20 also. Now, for step 4, find the relative frequency of values in each class. Let's begin with our first row. Using our formula, we have this frequency 3. We will write here over 20, that is the total frequency, times 100. And the answer is 15. And this 15 we will copy in here. Using the same formula, we will fill all the blanks here, and here we go. We have now the relative frequency percentage for each rows. And the total of the relative frequency percentage must be 100. Now, for step 5, add all the previous relative frequencies to the relative frequency for the current row. Okay, let us begin with the first row. This number 15 we will copy here, and for the next value we will add this 15 with this 25. So 15 plus 25 will be 40. Then 40 plus 15 will be 55. 55 plus 30 is 85. 85 plus 10 is 95. And 95 plus 5 is 100. The last entry of the cumulative relative frequency column is 100, indicating that 100% of the data has been accumulated. So we are done with our example 1. This is now our answer. Remember, because of rounding, the relative frequency column may not always sum up to 100. And the last entry in the cumulative relative frequency column may not be 100. However, they each should be close to 100. Let us have example 2, this time for grouped data. The table represents the heights in inches of a sample of 100 males semi-professional soccer players. Find relative frequency and cumulative relative frequency for the frequency distribution. This is now the given table. Now, let us write our step 1. For our table here, we are going to write 4 columns. In our first column, the heights are there, and we can see the classes. The frequency is here on the second column, and it is already given. So we don't need the tally column now. Next, we're going to find the total of the frequency, and this is equal to 100. This is based on how it is described in the problem that there must be 100 male players. Next is the relative frequency. This time, we are going to use this formula to express and show that relative frequency can be decimals also. Let's begin with our first blank. So RF equals the F, and that is the 5, over the N, which is 100. And the quotient is 0.05. We will copy this value in the first row. Next, we're going to fill in the full columns. Using our formula, we will have 0.03 in the second row, 0.15 on the third, 0.40 in the fourth, so on and so forth. If we get the total of this, we will get a whole number 1. Next, we will now fill in the cumulative relative frequency. For our first row, we will simply copy this 0.05. For the second row, we will add the 0.05 to the 0.03. So we have 0.08. And that pattern we will follow. 0.08 is added to 0.15, and that is 0.23. The 0.23 plus 0.40 will get 0.63. 0.63 plus 0.17, we will have this 0.80. 0.80 plus 0.12, we will get 0.92. The 0.92 plus 0.07 will have the 0.99. 0.99 plus 0.01 equals 1. So this is now the final answer. Remember, because of rounding, the relative frequency column may not always sum up to 1. And the last entry in the cumulative relative frequency column may not be 1. However, they each should be close to 1. Today we're going to study categorical frequency distribution. Categorical frequency distribution is a representation of data in tabular form showing categories with corresponding frequencies. Here are the steps on how to construct categorical frequency distribution. Step 1. List all categories in a column. Step 2. Tally raw data to corresponding categories. Step 3. Write the frequency for respective category with respect to tallies. Let us see one example here. 35 Army cadets were given a blood test to determine their blood type. The data set is given here. Construct a frequency distribution for the data. Complete the table below. In our table, we have 4 columns. The first column is for the category, which is the blood type. We can see here there are 4 blood types. We have A, O, B, AB, respectively. The next column is for tally, followed by another column for frequency. There is a column also for relative frequency. Now, let us begin with our tallying of the raw data. Let's begin with our first datum, that is A. We're going to tally this value in the column tally opposite category A. So we have here the tally, and we will strike out that first datum to be sure that we will not repeat that same datum again. This striking out of datum we will do on every raw data here. And to summarize, we have now the complete list of tally of our data set. And then let us go to the next column. This is for the frequency. We will simply count the tallies for each blood type. So for our first blank, this is for the blood type A, so we have 8. For the next, we have 14, and this is for the blood type O. The next frequency is 8 for blood type B, and the next is 5 for blood type AB. And then let us compute for the summation. We will take the sum of all the frequencies, and this is equal to 35. This number must be equal to the number of data in our data set. The next is, let us fill in the relative frequency column. The formula is given here. RF, that stands for relative frequency, equals F, that is the frequency, over N, that is the total of the frequencies, times 100. So for the first blank, we're going to have this number 8 divided by 35 times 100. And this is equal to 22.9. This value we will copy on the first blank. So there we go. And then we will use this same formula to compute for our remaining relative frequency. So we have this number 40. It comes from 14 divided by 35 times 100. This 22.9 here is the same with our relative frequency of the blood type A because they have the same frequency. So we use the same computation. Now, the 14.2 comes when we have this 5 divided by 35 times 100. And then let us take the summation of the relative frequency, and this must be equal to 100. By the way, the relative frequency of each category describes the frequency of the category in relation to the total frequency. And this is our final answer. Today we're going to study bar charts and pie charts. Let's begin with bar charts. Bar charts, or sometimes called bar graphs or bar diagrams, are used to represent categorical data. Bar graphs consist of bars that are separated from each other. The bars can be rectangles or they can be rectangular boxes used in three-dimensional plots, and they can be vertical or horizontal. These are steps to construct bar charts. Step 1. Draw a horizontal line and assign it to category, and vertical line for the frequency. Step 2. Represent each item in category by rectangles of equal width and height corresponding to its frequency. These steps will result to vertical bar charts. Interchanging categories and frequencies in step 1 would give a horizontal bar charts. Let's have an example. The following table shows the number of admissions at a training institute for the months January to June. Construct a bar chart for the data. We have a table here with two rows. The first row is for category month, and the months are listed January, February, March, April, May, and June. The second row is the number of admissions, or we can say the frequency. The first is 100 for January, 150 for February, 300 for March, 250 for April, 200 for May, and 150 for the month of June. Here is the bar charts corresponding to the given problem above. Take note that this is our horizontal line, and the category month is listed in here. Also, this is our vertical line here, and the number of admissions or frequency is assigned here. The vertical line is numbered on some intervals from 0, 100, 200, and 300. We stop on the 300 because the highest frequency here is 300 only. Please observe that our rectangles here are of equal width, and they represent each month with the corresponding number of admissions. The first rectangle here represents the month of January, and the height of the rectangle corresponds to the number 100 with respect to the frequency. The second rectangle is for February, and the frequency is 150. So the level here is between 100 and 200. The third rectangle is for the month of March, and this is the highest numbered frequency. The fourth rectangle is for the month of April, and the frequency is 250. You can see here that the level of the rectangle is between 200 and 300. The next rectangle is for the month of May with the frequency 200, and the height of the rectangle is on the level of the 200 frequency. The last rectangle is for the month of June, with the frequency 150. We can see also that the level or the height of the rectangle is in between 100 and 200. So we are done with our bar charts for our example, and this is our final answer. Let's go now to pie charts. Pie charts or pie graphs are also used to represent the categorical data. This representation gives emphasis to the relative weightage of each category. In a pie chart, a circle is drawn, and it is divided into sectors. Number of sectors will be the number of categories. The area of each sector is proportional to the frequency of the categorical variable it represents. These are the steps to construct pie charts. Step 1. Compute for the sum of all frequencies, denoted by n. Step 2. Find the percentage of each frequency, denoted by f, category by the formula percentage equals f over n times 100%. Step 3. Find the angle corresponding to each frequency category by the formula angle equals f over n times 360 degrees. Step 4. Draw the pie chart corresponding to angle and percentage of each item of the category. Let us see one example here. In a university, there are 400 students in the foundation program, 450 in the first year diploma, 350 in the second year diploma, and 250 in the higher diploma. Construct a pie chart for the data. It is advisable that we put the data in a table. I have here a table with 4 columns. The first column is reserved for the level, and the levels are foundation, first year diploma, second year diploma, and higher diploma. The next column is for the frequency. There are 400 students in the foundation program, 450 students in first year diploma, 350 students in second year diploma, and 250 students in higher diploma. There are 2 additional columns, namely percentage and angle, that we're going to fill in the blanks for these 2 columns. Let's go now to step 1, and that is to compute for the sum of all frequencies. Taking the summation of this column, we will have n equals 1450. Step 2. Find the percentage of each frequency category by the formula percentage equals f over n times 100%. Let's start with our first blank here. So we're going to use the 400, and that is the frequency of the first level, divided by the 1450, and then multiply to 100%. And the answer is 27.6%. we will copy this value on this blank, and here we go. For the second blank, 31%. We got this when we have this 450 divided by 1450 times 100%. The next blank is 24.1%, and that is when we have the 350 divided by 1450 times 100%. The last blank is 17.2%, and this comes from 250 divided by 1450 times 100%. After that, let us get the total of this column. We will have 99.9%, and this is equivalent to 100%. Now, let us go to step 3. Find the angle corresponding to each frequency category by the formula angle equals F over N times 360 degrees. Let's begin with the first blank here. It means, again, I'm going to use the frequency value and then divide by the N, 1450, times 360 degrees. This is equal to 99.31 degrees. This value we will copy on this blank. So we have now this 99.31 degrees. Next, for this blank, we will follow the same formula. So we will get 111.72 degrees. We will get this when we have 450 divided by the N, 1450 times 360 degrees. So the value is here. The next is 86.90 degrees. This value comes from the 350 divided by 1450 times 360 degrees. And the last blank is equal to 62.07 degrees. This comes from 250 divided by 1450 times 360 degrees. And the value is written here. Now let us take the summation of this column, and we will have the answer 360 degrees. This must be always equal to 360 degrees. On the same way that this column must have the summation that is equal to 100%. Now, let us go to step 4. Draw the pie chart corresponding to angle and percentage of each item of the category. So let us minimize our table because we are going to draw the pie chart. This is the finished product or the pie chart of this example. Please observe that in the pie chart, we are putting the percentage for each item of the category. Let's start with the first one, the foundation. So this 27.6% is written here. And for the angle, 99.31 degrees, it is estimated in the central angle. The next level is for first year diploma, which is 31%. And here is the 31% in red-orange color. And the central angle here is estimated to be 111.72 degrees. The third item is second year diploma with 24.1%. Here we go. And the angle is 86.90 degrees. And this is the angle. The last level is the higher diploma with 17.2%, and there we write the 17.2%, and the central angle is estimated to be 62.07 degrees. We can see here that our pie chart is colorful. However, in our daily class activity, what we can do is simply put each level opposite its corresponding sector. It means to say, the foundation program, we can write somewhere here. The first year diploma, we can write somewhere this side. The second year diploma may stay here. And the higher diploma, we can write somewhere here. And this is our final answer. Today we're going to study histogram. A histogram consists of contiguous or adjoining boxes. It has both a horizontal axis and a vertical axis. The horizontal axis is labeled with what the data represents. The vertical axis is labeled either frequency or relative frequency or percent frequency or probability. The histogram can give you the shape of the data, the center, and the spread of the grouped frequency distribution. Example 1. Draw the histogram for mathematics marks of 60 students. This is our table. Let us draw the vertical and horizontal axis. The vertical axis is for the frequency. We write the numbers and we made sure that the highest frequency is defined in our numbering. For horizontal axis, this is about the marks. We will consider the class intervals. Now, we will define the class limits from 0, 10, 20, up to 60. Now, let us start drawing the histogram, starting with the first class interval. Let us write the box for this first interval. From 0 to 10, the frequency is 2. This is the box. Second class interval. From 10 to 20, the frequency is 10. This is our box. Third class, from 20 to 30, the frequency is 21. Here it is. Next class, from 30 to 40, frequency is 19. Here we go. Next class, from 40 to 50, frequency is 7. This is our box. Last class, from 50 to 60, 1 frequency. This is our corresponding box. Now, our histogram is complete. Example 2. Given the histogram, answer the questions. There are 2 questions here. But before we answer, let us analyze the histogram here. This is about the ages of 25 teachers of a school. In our vertical line, this is the frequency of teachers. For our horizontal line, these are the ages in years of the teachers. And we put the class limits. Note that it started with 20, then 25, 30, 35 up to 50. That means the ages of the teachers are from 20 up to 49. Also, there are no teachers below 20 years old. Now let's answer the first question. How many teachers are of age 45 years or more but less than 50 years? This question corresponds to the last box from 45 to 50 and the frequency is 5. So the answer here is 5. Second question. How many teachers are of age less than 35 years? In our horizontal line, the number 35 is here. There are 3 boxes less than 35 years. So we add all the frequencies, 6 plus 5 plus 4, and the total is 15. There are 15 teachers who are less than 35 years old. There are frequency distributions with common value of class limits, just like this, and we are able to draw the histogram for this. However, there are frequency distributions with no common class limits. This is our example of frequency distributions whose class limits are not common. In this case, we're going to draw or construct histogram for this type of frequency distribution. Here are the steps to construct histogram. Step 1. Compute for lower and upper class boundaries of each class interval. The formula is given. For upper class boundary, that is equal to UL sub C. This UL means upper limit of the class interval, plus LL sub N. This is lower limit of the next class interval, all over 2. The upper class boundary of a particular class is equal to the lower class boundary of the next class. Step 2. Draw horizontal line and number it for class boundaries accordingly, and vertical line for frequencies. Step 3. Describe the classes by rectangles using lower and upper boundaries as width and frequencies as height, respectively. Let us see one example. For 108 randomly selected college applicants, the following frequency distribution for entrance exam scores was obtained. Construct a histogram for the data. We have a table here with 2 columns. The first column is for class limits or class intervals. We have 1, 2, 3, 4, 5 groups. The first class interval is from 90 to 98. The second class interval is from 99 to 107. The third is from 108 to 116. The fourth class interval from 117 to 125. The last class interval is from 126 to 134. The second column is for frequency. There are 6 observations for the first class interval: 22, 43, 28, and 9 for the other class intervals respectively. We need two more columns, and these are lower class boundary and upper class boundary respectively. Let us now solve for this first blank here for the upper class boundary, which is for the first class interval. The formula is given to us, which is upper limit of the class plus the lower limit of the next class divided by 2. It means to say the upper limit is 98 plus the lower limit of the next class, which is 99. So we see here 98 plus 99 divided by 2, we have 197 over 2, that is equal to 98.5. We will copy this value on this blank, and there we go. Next, it was stated that the upper class boundary of a particular class is equal to the lower class boundary of the next class. So we have 98.5 for this blank, which is the lower class boundary of the next class. Going to our upper class boundary of the second class interval, we will use the same formula. So we have 107, the upper limit, plus 108, the lower limit of the next class, divided by 2. This is equal to 215 over 2 equals 107.5. And this value we will write here. Again, this 107.5 we will copy down here as the lower class boundary for the next class. Then, let us compute for this upper class boundary of the third class interval. So we have 116 plus 117 all over 2. This is equal to 233 over 2, which is equal now to 116.5. And this value we will copy here. And this 116.5 will be same as the lower class boundary of the next class. Then, let us compute for the upper class boundary of the fourth class. We have 125 plus 126 divided by 2. And that is equal to 251 over 2. And the quotient is 125.5. This value we will copy in here. Also, this 125.5 is the lower class boundary of the next class. And there we go. Then let us compute for the upper class boundary of the last class. We may use our same formula here. But did you notice a pattern here? Looking at the upper class boundary, it seems that the upper class boundary is equal to upper limit plus 0.5. Look at this 98.5. We can see that the upper limit is 98 and this is 98.5. It's like the 98 plus 0.5 will give the upper class boundary, which is 98.5. The same is for 107.5, that is 107 plus 0.5, we will get this value. And that is also true for this 116.5 and also for 125.5. It means to say, using that pattern, we can simply get the value for our last blank, the upper class boundary of the last class, and that is 134, this upper limit plus 0.5, we will get 134.5 that we can write in here. Also, for the lower class boundary column, if we look at our lower limit, this is 99. It seems that this 98.5 is the result when we have lower limit minus 0.5. So you see, this is 99 minus 0.5 will give 98.5. Also, this 107.5 may come from 108 minus 0.5. This 116.5 comes when we have 117 minus 0.5. And the last, the 125.5 may come from 126 minus 0.5. On the same note, we can compute for this blank, for the value lower class boundary of the first class. We can get the lower limit 90 and then minus 0.5, and we will get this 89.5. We may copy now this value for our lower class boundary of the first class interval. Our table now is complete. Let us now write the histogram. First, let us draw the horizontal line and the vertical line here. In the horizontal line, we will write the class boundaries, and for the vertical line, we will write the frequency. Now let us describe the first class interval. Take note, the first class interval has lower class boundary of 89.5 and the upper class boundary is 98.5. So this is from this point up to this point in our horizontal line. So the rectangle corresponding to our first class interval is given here. The width is from 89.5 to 98.5 and the height is up to the level of 6 in the frequency. For the second class interval, we have the class boundaries from 98.5 to 107.5. So this is our interval, and the rectangle corresponding to that is this one with a height that is equal to 22 in the frequency. The third class interval has class boundaries from 107.5 to 116.5. And the rectangle for this class is given here with a height of 43 in the frequency. For the fourth class interval, we have class boundaries from 116.5 to 125.5. And the rectangle corresponding to this is given with a height that is equal to 28 in the frequency. For our last class interval, whose class boundaries are 125.5 and 134.5, the rectangle is given here with a height that is equal to 9 in our frequency. So this is our histogram now, and this is our final answer. In statistics, we use various tables and diagrams to represent data, which will facilitate easy interpretation and analysis of data. Frequency distribution is a representation of data in tabular form, showing classes or categories with corresponding frequencies. We are going to study two types of frequency distribution. The first, grouped frequency distribution. The second is categorical frequency distribution. For the grouped frequency distribution, there are steps to follow in constructing a grouped frequency distribution. The step 1 is to form the classes or class intervals. There are 4 sub-steps for this step 1. The first, or letter A, pick out the highest and the lowest values and find the range of the data. The formula for the range equals highest value minus lowest value. Letter B, determine the class intervals. Normally, the class intervals will be given in the problem. But if you are a researcher, you will be the one to decide on the number of class intervals. It says here, number of intervals should be between 5 and 12, and they usually have equal widths. Letter C, find the class width, denoted by I, by dividing the range by the desired number of class intervals and round up the quotient. Step D, write the first class interval using the lowest value as the lower limit, and the upper limit is the value of lower limit plus class width minus 1. Write the next class intervals accordingly. Step 2, tally the values in the data set into the classes formed. Step 3, find the frequency of each class by totaling the tallies. Step 4, construct a column of relative frequency distribution using the formula RF, that stands for relative frequency, equals F over N times 100. Let us see an example. The average quantitative GRE scores for the top 30 graduate schools of engineering are listed. Construct a grouped frequency distribution with 5 classes. We have here 30 raw data representing the GRE scores of 30 graduate schools of engineering, and let us now construct a group frequency distribution. The step 1 is to form the classes or the class intervals. Let's start with step 1A, and this is to find the range. First, let us identify the highest value and the lowest value. Browsing through the data, we can see that the highest value is this 780 and the lowest value is 746. So the range is, to get the difference, R equals 780 minus 746, and this is equal to 34. Step 1B, we will determine the number of classes, and it is given already in our problem. So there will be 5 classes. Step 1C, to compute for the class width, symbolized by letter I, and this is equal to the range divided by the number of classes. So we have 34, that is the range, divided by 5, the number of classes. This is equal to 6.8. So this quotient we need to round up, and this is now round up to 7. Take note that this is rounding up and not rounding off. For further examples, we may say that this 6.1 is round up to 7. Also the 6.3 is round up to 7. Along with 6.5 and 6.9 are all rounded up to 7. The 6.0 is rounded up into 6 itself. So it means to say, we can conclude that any decimal added to the number 6, it will be rounded up to the next whole number, which is 7. Let's go now to step 1D. Write the first class interval using the lowest value as the lower limit. We can use a value a little lower than the lowest value, depending on the purpose of the author. And I will continue. And the upper limit is the value of lower limit plus class width minus 1. Write the next class intervals accordingly. At first, we need to show a column for class intervals. For our first class interval, we will write the lower limit. In this example, we will use the lowest value, the 746. That is our lower limit of the first class interval. And then, for the upper limit, the lower limit itself plus the class width, which is 7, but we must have to subtract 1. And when we simplify this, this is equal to 752. And we will put this value in here. It means to say, the first class interval is starting from 746 up to 752. So when we count, there are 1, 2, 3, 4, 5, 6, 7 numbers for the class interval. And the 7 numbers is the one being described by our class width, which is 7. And then we will continue to write the next classes. For the second class, we ended our first class interval into 752. So the next class must start with 753. And this 753 is the lower limit of the second class interval, and the upper limit is 759. We follow the same pattern based on our first class interval, and that idea will be implemented on the other class intervals. So in here, we are able to write all the class intervals. So let us check. There are 1, 2, 3, 4, 5 class intervals as required by our problem. Also, let us check with our lowest value, the 746, that it belongs to the first class interval. Also, the highest value, the 780, belongs to the last class interval. So we are checking here that all the numbers or raw data will find a specific class interval. Next is, we will go now to step 2, and this is to tally the values in the data set into the classes form. We need a column for tally. So what we're going to do is to go through each of the data We will tally them according to their respective classes. Let's begin with the first number, the 767. And this number belongs to this group. We will strike that number and put a tally corresponding to that datum. Next, the 770 also belongs to this group. So we will go through each of the data. So this is now our complete tally list. For the step 3, let us find the frequency of each class by totaling the tallies. So we need another column for the frequency. We will simply count the tally for each class intervals. So it means for the first class interval, we can see here that there are 4 tallies. So we will write here 4 in the frequency. For the second class interval, there are 6 tallies. For the third class intervals, there are 8 and 9 and 3 for the fourth and fifth class intervals respectively. Next is, we will take the total of the frequency, and this must be equal to 30. It means we did not miss anything in our raw data. For step 4, let us construct a column of relative frequency distribution using the formula Rf equals F over N times 100. So we need a column for the relative frequency, and our formula is here. For the first blank here, it means we're going to use the frequency of this first class interval, which is 4, divided by the total number of frequency, which is n, the 30. So you see here we have 4 over 30 times 100. And the answer is 13.33. This value we will put on this blank. And there we go. So let us complete the remaining blanks using our formula here. So this number 20 comes when we have the number 6 divided by 30 times 100. This 26.67 comes when we have 8 over 30 times 100. This number 30 comes when we have 9 divided by 30 times 100. This number 10 comes when we have 3 over 30 times 100. So we are now complete with the values for the relative frequency, and at the bottom we're going to take the summation, and the value must be equal to 100. This is our final answer. Problem 1. The heights in inches of commonly grown herbs are given below. Organize the data into a frequency distribution with 6 classes. Here are the data. The first thing to do is to find the range. The formula is highest value minus lowest value. On the data, we identified the number 36 to be the highest, the number 7 to be the lowest. So the range is 36 minus 7. The answer is 29. Next step, we're going to divide the range by the number of classes desired. The range is 29. We divide this by 6. In the problem, we want 6 classes. So the quotient is 4.86. We will round this up into 5. This number 5 is what we call the class interval. Now we write the classes. We begin with the first class. the lower limit or the first number is this number 7. Then we write the upper limit. The formula is lower limit plus class interval minus 1. The class interval here is 5, minus 1 is 4. So that means 7 plus 4. So that is 11. So the first class is from 7 to 11. On the next class, we begin with the next integer. 11 becomes 12, and then plus 4. That will be 16. Next group, from 17 up to 21. 22 up to 26. 27 to 31. 32 up to 36. Next column, we put the tally. That means for each of the raw data here, we're going to put them in their respective classes. Let's begin with 15. We put one tally here. Then 36, it belongs in this class. So finally, all tallies are here. Then the frequency. Simply we count the tallies per class. From 7 to 11, frequency is 2. Here is 3. Next, 9. The next group is 2. Next class is 0. And the last class is 1. Note that the total or n equals 17. Note that there are 17 items or numbers in our given. Next is the relative frequency. This is given in percent. So what we do, this frequency 2, we divide by n, the 17, then multiply by 100. So it becomes 2 over 17 times 100, that is 11.76%. Next, 3 over 17 times 100, that is 17.65%. Next, 9 over 17 times 100 equals 52.94. So on and so forth. If we get the total of this relative frequency, we will get 99.99. That is equivalent to 100. Last column is the cumulative frequency. On the first blank, we copy this number 2. Then 2 plus 3 becomes 5. 5 plus 9 is 14. 14 plus 2 is 16. 16 plus 0 is 16. 16 plus 1 is 17. The last number here must be equal to the n. Problem 2. The ages of the signers of the Declaration of Independence are shown. Construct a grouped frequency distribution for the data using 7 classes. Let's find the range. We identified the range to be highest value minus lowest value. The highest value is 70, lowest is 27. So the range equals 70 minus 27, that is 43. We note the range to be 43. Then we go to the next step. Divide the range by the number of classes desired. We want 7 classes. So that means 43 divided by 7. The answer is 6.14. We will round this up. So the number is 7. This 7 here is the class interval denoted by I. Let's now write the classes. For the first class, we begin with the lowest value, the 27. Then we write the upper limit, that is lower limit plus the class interval minus 1. The class interval is 7 minus 1, that is 6. So 27 plus 6, we get 33. So the first class is 27 up to 33. For the next class, we continue the next number, 34, plus 6 is 40. Then 41 up to 47. Next 48 up to 54. 55 to 61. 62 up to 68, 69 up to 75. Then we write the tally. Each of these raw data we will put on their respective classes. Let's begin with 41, one tally here, then 54. And finally, we get all these tallies. For the frequency, we count the tallies respectively. We get here 7, 14, 15, 11, 3, 3, 2. And the total is 55. That is N. For the relative frequency, this 7 divided by N times 100. The answer is 12.73. This is in percent. Next, 14 over 55 times 100, 25.45. 15 over 55 times 100 equals 27.27. So on and so forth. And the total of the relative frequency is 99.99. Actually, this must be 100. Next is cumulative frequency. For the first blank, we copy the number 7. Then 7 plus 14, 21. 21 plus 15, 36. 36 plus 11, 47. Then 50. Then 53 plus 2. Then 55. The last value here must be the same with the value of N. Problem 3. There are 216 employees in a factory as per list given. Electrician 72, plumber 62, fitter 37, supervisor 28, clerk 17. Represent the data using bar graphs. This is the bar graph for electrician 72 number. Plumber got 62, fitter got 37, supervisor has 28, and clerk 17. This is the bar graph for this data. What about pie graph? Let's put this in another table in a vertical one. Then the total is 216. Then we write the relative frequency. And the formula is F over N times 100. This is in percent. So 72 over 216 times 100, that is 33.33%. 62 over 216 times 100 equals 28.7. So on and so forth. The total here must be 100, or in this case 99.99, and this is equivalent to 100. Next is we compute for the corresponding angle with regard to 360 degrees. So the relative frequency in decimal we multiply by 360 degrees. Here is 33.33. Remember, this is in percent. So what we do, when we convert this in decimal, that will be 0.3333 times 360 degrees. The answer is 119.99 degrees. Next, here is 0.287 times 360 degrees. We will get 103.32 degrees. 0.1713 times 360 degrees. We will get 61.67 degrees. 0.1296 times 360 degrees. That will be 46.66 degrees. And for the last one, 0.0787 times 360 degrees. That is 28.33 degrees. The total here is 360 degrees. And this is now the pie graph. This is for electrician, plumber, fitter, supervisor, and clerk. Problem 4. 30 automobiles were tested for fuel efficiency in miles per gallon. The following frequency distribution was obtained. Construct a histogram for the data. We have here class boundaries and the frequency respectively. The first class will be 7.5 to 12.5 with a frequency of 3, so on and so forth. So we draw a horizontal and vertical line. The y-axis is here, that will be for the frequency. For the x-axis, that will be for the class boundaries. Then we draw the corresponding values. Here are the class boundaries. Here are the frequencies. Let's begin with the first class. From 7.5 to 12.5, it's here. And the frequency is 3. So we put the height as 3. Then the second group, 12.5 to 17.5 with a frequency of 5. So here it is. Next group, from 17.5 to 22.5. The frequency is 15. So the height of the building here is 15. Next group, 22.5 to 27.5. The height is 5. Next group, 27.5 to 32.5. The height is 2. So here it is.